Being square or using the square shape is one of the most important things that a tradesman can use and know about. So welcome to this video on the geometry of a square. As we said, we've got a length and each side of a square has the same length, all at right angles to each other. And from there we can actually work out its perimeter, its area, and the actual length of its diagonal. So the perimeter is just 4 times the length. It's all the way around. If I opened it out, how long would that be? Sometimes you can write it as 4 times L, or you could just say 4L. For the area, that's actually the space inside an object, and that would be L times L, or L squared. So 2 dimensions, length and a width, that's where I get the squared from. So for example, if I had 1 metre by 1 metre, that is 1 square metre of area. If I had a 2 by 2, I could put my little 1 squares over the top of it, and I could see that I have an area of 4. So even though I've got a perimeter of this shape, so the perimeter is 4 times 2, because it would be 2 plus 2 plus 2 plus 2. That would be 8. I have an area of 4. So I have an area of 2 times 2, which is 4. 2 squared is 4. Here, my perimeter is 4 times 1, which is 4. So we could count squares all the time, but realistically, what we do is we take the length and the width and we multiply them together. So on this square, if I had 3 by 3, I would have a perimeter of 4 lots of 3, 3 plus 3 plus 3 plus 3, and I would get 12, and I would have an area equal to 3 squared, or 3 times 3, which is 9. So the area here is 3 squared, which is 9. So to get the side length, if I'm given the area, I unsquare it, and unsquaring is taking the square root. So the square root of 9 is 3. That's what gives me that side length. If I had an area equal to 5, what I'm saying is, well, how do I work out that side length? Well, the area is 5, so that the length of this is the square root of 5. Because the square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is 5. So that would give me an area of 5. If I had an area of 18, so if I said the area was 18, right, you can actually see that inside that 18 is a perfect square, which is 9. So 9 twos are 18. So I'm going to break this up into 9 squares, and I'm going to put a 2 in each of them. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So there's, you can see my area. So what I actually want to know is the side length will be the square root of 18, right? So each side length is going to be the square root of 18. What is that as a number? Well, let's have a look. Each of those mini squares, if you like, each of those mini squares has a side length of root 2, because root 2 times root 2 gives me square root of 4, which is 2, sorry. That means that this length is also root 2, and this length is also root 2. So I have actually got 3 lots of root 2 as my length. And we can work that out as a decimal. I'll get my calculator up. And there it is. So let's just press in the square root of 18. Now you may have to press in the 18 first and then hit the square root button. It depends on your calculator. So the square root of 18 is, as a decimal, 4.243. That means if I did 4.243 and I multiplied it by itself, I squared it, 4.243, I would get back what I started with, my 18. So now let's just have a look at this 3 root 2 that we came up with. So I'm going to say 3 times, now I've got to take the square root of 2. So the square root of 2 is 1.41. So 1.414. And then it's going to multiply by 3 when I hit the equals button. And there again is my 4.242. So you can see that as a decimal, the square root of 18 is 4.242. 243. 3, I think I had, didn't I? So let's have a look. We know from Pythagoras that a squared plus b squared equals c squared. This is my equals sign. So c squared equals a squared plus b squared. And you can see also from this picture that a squared will be this c squared take away the b squared. Or I could say b squared equals c squared minus a squared. So everything is in there. So if I had a triangle that was a right angle and I had a side length of 1, this would be c, and I could say c squared equals 1 squared plus 1 squared, a squared plus b squared. They happen to be both the same because it's square. 1 squared is 1, 1 squared is 1. So I actually get some number squared equals 2. So c squared equals 2. How do I unsquare a number? I take the square root of it. And the square root of 2, if you remember from calculator, I'll just bring it up just to show you. Right, the square root of 2, clear that. The square root of 2 is 1.414. So let's have a look at what happens when I scale my square up. So if I had, for instance, what if I had a 10 by 10 square? So I know my 10 by 10 square, my 10 by 10 square has a perimeter equal to 4 times the length, which is 40. It has an area equal to L squared, so that is 10 by 10, which is 100. Now we're going to look at what's the length of that blue line diagonal. So again, I know if this is the long side, right, I've got 10 and 10, so c squared equals the two shorter sides squared, 10 squared plus 10 squared. BODMAS tells me I do the squared first, the indice, the power of the exponent. So I have to do that first and then add them. So there's some number out there that when I square it, I get 200. Well, that number is the square root of 200. So let's do that on our calculator. And let's see how that goes. So the square root of 2 is 1.414. Let's do 200 and take the square root of it. 14.14. 10 times bigger. Interesting. So this is 14.14. It's actually 10 times the square root of 2, 10 times my 1.414 that I had. That's because that's actually the square root of 100 times 2. What is the square root of 100? It is 10, but I've still got my square root of 2. So what it says is that if you have any square, so this is a square, not a rectangle. So for example, if I had a 5 and a 5, I immediately know that this will be 5 square root 2 because all squares scale in proportion. A square that is in 3D becomes a cube. That's the object, and I would talk about the volume of a cube. So I hope that's helped you understand squares a little bit better, and I look forward to seeing you at the next video. Thank you.